Hello everyone, this is Jennifer. So in this video we're going to look into the determinants of a matrix. So to every square matrix is a unique number is associated called the determinant of the matrix. The determinant of a matrix is a scalar number obtained from the elements of the matrix by special or specific operation which is characteristic of the matrix. The determinants are defined only for square matrices wherein the order of the matrix is always equal, that is, your number of rows is equal to your number of columns. It is denoted by the term det A or A. You have your line on both the sides of A for a square matrix A. So it is read as determinant of A or not the modulus of A. So for example, as an example, if we show this determinant of order 2, which is the order of the matrix is 2 into 2, which is 2 rows and 2 columns. So let A be A11, A12, A21 and A22, which is a 2 into 2 matrix. Then the determinant of the matrix is A11 into A22. So you just cross multiplying kind. So A11 into A22 and A12 into A21. So when you multiply that, you minus it, and that is called the value of the determinant. So now if you look into the real questions. So first question, A matrix, you have 2, 3, 1, 2 in your question. So the determinant of the matrix will be just cross multiply. 2 into 2, which is 4, 3 into 1, which is 3. 4 minus 3 is 1. Okay, just cross multiply and minus it. That is the value of the determinant. Here they have given 2, 5, minus 4 and 1. 2 into 4 is 8. 5 into minus 1 is minus 5. So minus into minus will become plus. So 8 plus 5 is 13, the higher degree sign, which is plus. So the next, the determinant of a 3 into 3 matrices. So the order of the matrix is a square matrix wherein the order is given, which is 3 into 3 order. How are we going to find out the value of a determinant in such a case? So let A be, they have given the matrix which is 11, 12, 13, 21, 22, 23, 31, 32, 33 is your matrices. Be a square matrix of the order 3 into 3. Then therefore your determinant, how will you find out your determinant in this? You need to cross multiply, right? So you need to split out the entire matrix into 2 into 2 order matrices. So your first row, that will get split up. So your first row, A11, A12, A13, okay, that will be split up. Then what you're supposed to do is split up the down matrix into small cubes of determinants, okay. So if you have A11, so the next matrix, second row and the third row numbers will be taken, which is A22, A23, A32 and A33. So if you move on to A12, so you'll move on to the first, which is A21, A23, A31, A33. So you'll leave the number that is below that particular number. So A13 into A21, A22, A31 and A32. So now you can cross multiply and you can minus it, then you get the value of the matrices. So now let us move on to the question. Example 1, they have given the matrix. So if you cross multiply 2 into minus 1, minus 2, 4 into minus 5, 20. So minus into minus will become plus. So minus 2 and plus 20 will become 18, which is a greater number sign. And you minus it because plus into minus is minus. So plus into minus is minus. Example 2, evaluate 3 into minus 5, minus 2, minus 1 and 3. So 3 into minus 5 is 15, minus 15, minus 1 into 3 is plus 3, which is minus into minus plus. So minus 15 and plus 3 you get minus 12. So example number 3. So evaluate, they have given the matrix. So you're supposed to find out the determinant of a matrix. The matrix is equal to the first row will be split up. So 3, minus 4 and 5. So you will have minus and plus. Okay, so that is how we will go. Then the first row is split up into the small numbers. Now you have to have your inside determinant. So the first row, first number 3 into the number which is to the next row and the next column. So 3 into 1 minus 2, 3, 1. So okay, which is not part of the first row or the first column. So you just delete this and this because you are considering this 3 number. So the remaining balance is 1 minus 2, 3 and 1. The same way minus 4. So when you take the minus 4, so you delete this number, this row, and you particularly delete this column and this row. So the remaining numbers will be 1, 2, minus 2 and 1. So when you take this third number which is 5, so you delete this particular column, the balance is 1, 1 and 2, 3. So when you multiply, you'll get minus 1 into 1, 1, minus 2 into 3, 6, plus 6. So 1 into 1, 1, minus 2 into plus, minus 2 into 2 is 4, which is minus into minus will come plus. 1 into 3 is 3, 2 into 1 is minus 2. So when you add and subtract, so it will be 3 into 1, 1 plus 6 is 7, 1 plus 4 is 5, 3 minus 2 is 1, 3 into 7 is 21, 4 into 5 is 20, 5 into 1 is 5. So the resultant figure is 46. So our next question, they have given the A matrix and they is telling us to find out the A determinant by expansion by first row and first column. So if you have expanded by first row, you will have your outside number to be the first row numbers. So if you have the first column, you will have the outside number to be the first column, which is 3, 0 and plus 1, which will be the first two determinant will have minus and the third determinant you will add it. So if you, for example, we'll start with the first row. So the first row will first be splitted, which is 3, minus 2 and plus 1. Okay, the inside determinants will be of the remaining numbers. Okay, so when you add and multiply, you get your first determinant value, and the first, when you expand it by row, you get a 25, and the same way when you expand it by column, you get 25. So in the column, you will expand the first split up by column 3, minus 0 and plus 1. So the inside determinants will be based on the balances. So if you multiply and add, you will again getting A determinant to be 25. So our next question, which is if determinant, they have given A determinant, which is A5 minus 8 and 4, which is equal to 0, find value of A. So they have given the value of the determinant, you're supposed to find the value of A. So 4 into A, 4A, 8 into 5. Okay, minus 8 into 5 is 40. So minus into minus is plus. So 4A plus 40 is equal to 0. A is equal to minus 40 divided by 4. Therefore, the value of A is minus 10. So next question, find the value of X if, and they've given the matrix which is equal to 0. Now it is basically a 3 into 3 matrix. So it will be 1 into 8. 8 into x, 0 into 5, 0. So 8x minus 0 minus 4 into 2 into 8, 16, 0 into 3, 0. Okay, plus 5 into 2 into 5, 10. X into 3 minus 3x, so which is equal to 0. So when you multiply it, 8x minus 64 plus 50 minus 15x is equal to 0. So minus 14 minus 7x is equal to 0. 7x is equal to 14 divided by 7, therefore the value of x is minus 2. Now let us move on to the next topic, which is the Kramer's rule. So our next question, solve the given equation by Kramer's rule. So Kramer's rule, basically you have two equations that will be given. So you're basically supposed to find out the value of the variables, which is how many variables do we have in the question, x and y. So we're supposed to find out the value of the variables. So now basically we will convert this equation into a matrix. Okay, first you will have the x matrix, so 3, 2. Okay, and the y matrix, 6, minus 6 and 3. So which is matrices X, you can denote it by any alphabet. Here we're denoting it by A, so which is matrix A. And matrix B will be the constants, which is 7 and 15. So the matrix A is nothing but the coefficient of the equation and the matrix B is the constant. So now let us find out the determinants of the matrix. So 3 into 3 is 9, minus 6 into 2 is 12. So minus into minus plus, 9 plus 12 is 21. And AX. So now you are supposed to find out the the determinant of AX. So in the determinant of AX, in the place of X values, which is 3 and 2, you will put the constant values, which is 7 and 15. So 7, 15 minus 6 and 3. So again you cross multiply to find out the value of the determinant. 7 into 3, 21, minus 6 into 15, 19, which is equal to 111. And AY, now in the place of Y coefficient value, you will put the value of constant, which is 7 and 15. So 3, 2 and 7 and 15. So 43 into 5, 45, 7 into 4, 14. So 45 minus 14, 31. Therefore the value of X is determinant AX, which is 111, divided by determinant A, which is 21. And the value of Y is determinant AY divided by determinant A, 31 divided by 21. Okay, so in the same way you will find out the value of the next question. Solve the following equation by Kramer's rule: 10x plus 5y plus 120, which is equal to 125, and 9x plus 12y, which is equal to 150. First you convert the equation into a matrix, which is 10 and 9, which is the value of the x, the coefficient of the x, then 5 and 12, which is a coefficient of y. Then you have the constant, which is 125 and 150. So now let us find out the determinant of A matrix. 10 into 12, 120, 9 into 5, 45, 120 minus 45 gets 75, and A value of y is, in the place of the y coefficient, you put the constant numbers, which is 125 and 50. So 10 into 150, 1500, 125 into 9, 1125. The value is 375. So the AX is, in the place of x, you'll put the value of the constant, which is 125 and 150, and 5 and 12. 125 into 12 is 1500. 5 into 150 is 750, which is equal to 750. So therefore the value of x is AY determinant divided by A determinant, which is 375 divided by 75. The value is 5. And x determinant is AX determinant divided by A determinant, 750 divided by 75, which is equal to 10. So the value of x is 5 and the value of y is 5. The value of y is 5 and the value of x is 10. So now let us move on to the next question. Find the cofactors of matrix A. So they have given the matrix A. You're supposed to find the cofactors. So if you see in determinants, basically we were hiding the other numbers when just basically splitting or expanding the matrices. But cofactors is quite different, wherein we are supposed to find the cofactor of each number of the particular matrix. So we have a 3 into 3 square matrix. So I will tell you clearly how we basically do it. So basically we start with each number or element in the matrix. So your first number is 5. The 5. So this is C11, the first row and the first column. So C11, which is equal to minus 1. Always you will have the formula starts with minus 1. First row and first column to the power of 1 plus 1. First row, first column. So now the determinant of this will be, so if you hide this row and this column and this particular row with the 5 is there, after the hiding part the balance will be 1 2 2 1. So 1 2 2 1. So now you're supposed to basically solve it. So 1 into 2, 1 into 1 is 1, 2 into 2 is 4. So 1 minus 4 and 1 to the power of square. So minus into minus, which is equal to plus. So plus into minus is minus 3 is your answer. So that is how you're supposed to find out each and every element. So the second element, which is 2, which is first row and second column. Okay, so minus 1 into first row plus second column. So the determinant will be 3, 1, 1 and 2, because you will hide the first row and this particular last column, which is equal to 3 into 1, 3, 2 into 1, 2, 3 minus 2 is minus 1, 1 to the power of cube is minus sign. So minus in 1 to plus is minus 1. So like that you will find the factors for each and every element. Okay, therefore finally you get the cofactor of wherever we have found out. So C11 will be minus 3. So the first row and first column will be minus 3. So like that you will write down the value that we have found out for each thing and a matrices. So thank you everyone.